Hello, everyone. My name is Andrew Boyd, and I am the project manager for the structures team on the City of Yelm Water Tower project. In order of appearance in this presentation, and they will all introduce themselves as they present, we have John Gonzalez, who is the hydraulics lead, Raiden Uwicki, the foundation lead, and Kai Ortega is the assistant project manager and drafter lead. The City of Yelm requires an increase in their water storage capacity because the population is projected to increase approximately 3.5% per year for the next 10 years, and their current capacity does not meet fire suppression requirements. The objective of this project is to design a water storage system that contains over 1.5 million gallons on a lot in the southeast corner of the city limits. After performing an analysis of several alternatives, a steel standpipe reservoir was selected. This option was chosen over a concrete standpipe, an elevated steel tank, an underground steel tank, and the do-nothing alternative. The steel standpipe was determined to be the most viable option for several reasons. One, it met the client's demand, while the do-nothing alternative, of course, did not. Steel is a material that has great longevity compared to concrete. The cost of material is high, but less is required compared to a concrete reservoir. Once the reservoir is constructed, maintenance costs will be considerably less for the standpipe compared to the underground reservoir because it's more easily accessible. And while the steel is not exactly aesthetic, it is easily paintable, so that covers that criteria. And a steel standpipe has easier construction than an underground or an elevated steel tank.
So the project is located to the southeast of Yelm, north of the Walmart Supercenter. Slide. This shows the overhead view of the site plan. The footprint is proposed in the southwest corner of the lot, which is the most level area on the site. There is also the least amount of trees encroaching on the foundation of the site, and therefore the least amount of trees needed to be removed. There is a existing slab that needs to be removed to the northwest of the foundation, and the site entrance is to the north.
The tank will be 128 feet tall based on the hydraulic level required by the City of Yelm, and 46 feet in diameter based on calculations for the capacity. The wall plates will be 4 feet by 8 feet and supplied by the cost estimate by metalsdepot.com. They will be ASTM A36 steel sheets and oriented in a brick-laid configuration to avoid excessively long weld connections. The thickness of the walls will vary as the height increases due to a decreased stress on the plates because there's less water above it. The ground level plates will be 1 1/8 inch thick and decrease by 1/8 of an inch at every level. This thickness is based on availability on metalsdepot.com and includes a corrosion allowance of over 1/16 of an inch by default. The plates will be connected via complete joint penetration welds. The anchor chair will hold the reservoir on the foundation and was designed based on the seismic overturning moment. The plates of the anchor chair will be 18 inches long per AWWA minimums and 1 inch thick. The bolts will be Simpson strong tie pre-assembled bolts version 7 that are 1 inch thick and spaced 3 feet on center. These bolts will be 80 inches or more long for adequate embedment in the foundation.
Our foundation will be 76 feet in diameter and 3 feet thick to create a satisfactory bearing pressure on the soil of less than 3,000 psi. The foundation will be concrete reinforced with number 8 steel rebar. And there will be a ring wall on top of the foundation that will provide extra support to the structure, and the ring wall will be 4 feet tall and 2 feet thick. The foundation will have a clear cover of 3 inches, and the rebars will be 225 inches long, spanning in one direction. The rebars will have a development length of 4 feet. There will be 2 layers of rebars within the foundation, and a 30-inch distance in between each layer. One layer of rebar should have about 434 number 8 rebars, adding up to a total of 868 rebars needed for both layers. And the allowable stress that was calculated was 2.95 KSF, which is well below the 3 KSF limit.
The pipe network will consist of 2 main pipe sizes. For the inflow and outflow pipe, they shall be 8-inch diameter galvanized steel with a maximum flow of 1,600 gallons per minute, where the overflow pipe will have a size of 10-inch diameter galvanized steel with a maximum flow of 3,000 gallons per minute. These pipes will be designed to allow for up to 1 inch of travel as per AWWA D100-11, section 13.6, table 30 for seismic design. This is an overhead view of the site. The 8-inch inflow pipe will enter through the north side of the tank up 128 feet, while the 8-inch outflow pipe will exit through the center of the tank and out on the east side through the ring wall. The inflow and outflow pipes will then connect with 2 check valves and have a single pipe headed out and connected to the main. The 10-inch overflow pipe will exit on the south side of the tank through the ring wall and will have a coarse corrosion resistant screen mesh or flap valve as per AWWA D100-11, section 7.3.
There are some aspects of the water reservoir that must be outsourced for design, with one of them being the roof. The roof must be a self-supported dome with about 3 feet minimum for freeboard. This roof also must meet the AWWA roof slope requirements, where if the slope is less than 2 to 12, there are no requirements. If it is in between 2 to 12 and 5 to 12, the surface must be an unskid surface. And if it's greater than 5 to 12, it must have ladders and guardrails. And WAC 296-155-24609 must also be used when designing the roof, as it provides requirements for guardrails. Another aspect that must be outsourced for design will be the ladders, landing platform, and the ladder cages. This must be designed using WAC 296-876-50010, ANSYS A14.3-2002, and AWWA 100-5. These provide minimum spacing requirements for the ladders, cages, and the landing platforms. The landing platforms must be spaced 30 feet max, although the ladder itself says it's 50 feet max. It must be designed using the 30 feet maximum spacing for each landing platform. The last aspect that must be outsourced for design will be the access hatches. We have provided general areas as to where the manholes would be, with one being on the roof and two in the first ring of the water reservoir, per AWWA D100-11, that states that there must be a minimum of 2 round or elliptical shell manholes within the first ring. 2 of the manholes that we've indicated must have a 24-inch diameter, and the remaining one will be a 30-inch diameter manhole. And if the hatch weighs more than 50 pounds, then hinges or davits are required. Throughout the design process, we've used this design criteria to determine all the accessories and design guidelines that we need to meet. We've used sources by the Washington Administrative Code, Thurston County, Washington State Department of Health, the American Water Works Association, and the City of Yelm to assist us throughout the design process. The Washington Administrative Code provided a lot of details in terms of locations of lighting, water system planning, and others that are not noted here also include the ladder design, and the American Water Works Association was primarily used throughout the design of the structural components of the water reservoir. When designing for the water reservoir, we've established 5 different risk levels, and we've assigned it to 5 different events that could happen. We've ranked these risk levels based on the impact that it would have on the community, with 5 being the highest and 1 being the lowest. So we decided to have the structural failure, mechanical failure, and the water contamination to be the highest risk levels. So those are the things that we've designed for, with the labor strike and vandalism being lower at 2 and 1 respectively. Because we are designing for these risks, we decided to assign an event probability, with 1 being the lowest, and for our risk analysis, we made it 2 the highest. So for structural failure, mechanical failure, and water contamination, since these are the things that we are designing for, we assigned it a event probability of 1. Labor strikes and vandalism is unpredictable because of human nature, so we decided to assign that as a event probability of 2. To address the sustainability aspect, we've narrowed it down to 3 different sections: economic sustainability, environmental sustainability, and social sustainability. To address the economic sustainability, we are designing it to use the least amount of material, and to do that, we decided to shrink the plate thickness as it went up. So basically, it's just tapering up. For the environmental side of things, we are striving to cut down as few trees as possible, and the overflow pipe will have a dechlorination system before the overflow water enters the stormwater system. And for the social aspect, we are trying to, or we have sized the steel plates so that it is easier to transport, meaning that it would have less of a traffic impact.
The tower cost includes the steel sheets for the walls, the concrete and rebar for the foundation, the excavation and backfill, the pipes and the pipe connections. Not included in this cost estimate are the accessories to be designed by the contractor and the anchor chairs. The steel sheets and pipes were estimated from metalsdepot.com, hence the specific sizing and thicknesses. And the foundation costs, the excavation, the backfill, the concrete, and the rebar were estimated from a WashDOT construction cost estimate website. Adding these all up, we determined the cost to be $2.4 million, and with a factor of 1.15 to account for the undetermined and outsourced costs, we estimate the cost of the tower to be $2.72 million.
These are the additional resources that we used throughout the design process. Feel free to pause and take a look at the links that we provided. Now, as for the next steps and deadlines that we'd have to meet, we have the Scholars Day presentation on April 25th and the 100% design that is due on the 3rd of May.
And that's all we have for you today. Thank you for your time and have a wonderful rest of your day.